to be able to trace the flow of blood. Be sure you're comfortable in doing that. You want to start entering through the superior inferior vena cava, and then you trace properly. Don't forget the valves. I want you to be able to trace properly the flow of blood. And you need to remember the difference between pulmonary circuit and your systemic circuit, right? And then
Now the valves, it's the tricuspid first, the bicuspid,
yeah,
and then the semilunars, or is it the bicuspid, tricuspid, then the semilunar?
Neither.
just AV valve. So look at figure 18.1. So this one is showing you the flow of blood.
What chapter? What page?
Page 674. Figure 18.1. Okay.
That's from the newer edition.
Do you have the new edition?
No, I have the old one.
So this is lines it's showing you.
I have it in here. It's just not
Blood
on that
flow
page.
through the heart. Focus 18.1. Blood flow through the heart. You're way. You're already in the blood vessels.
Oops.
Go back.
This one?
669.
For the old one.
Okay, here we go.
And then I remember we talked about the difference between the right and the left.
It says tricuspid valve right there.
The AV valves, yeah. So
It's the same thing, right?
Yes.
Tricuspid is the same thing as the AV valves.
That's right.
Okay, that's what I thought. I was
Just-
like, what? She's like, neither, and I'm like, no, it's this
Just
right
be
here.
able,
Tricuspid
just
valve.
be able to.
It's the AVs.
I know, but it says
Then the
tricuspid.
semilunars.
Yes. Okay.
Okay.
So then, of course, the pacemaker right here. Just know the physiology. Okay. Know the how the heart contracts. So I remember I talked about this cardiac cycle. Look at figure 18.9. This one for sure.
9,
If you know the cardiac cycle, then you're going to know the story of the heart. This one. 18.19, figure 18.19, right?
18,
No, yours is another
19.
one too.
And EKG.
I don't know if we even had that picture in this book.
Yeah, it's
Oh, there it is. 680. Okay.
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 And then
Already.
EKG. You know what happens to the EKG, the events of the EKG, right? You go back, figure 18.17, it's already telling you the story of what happens with and then you have some examples here. For sure, there will be some EKG tracings there. So you know how normal EKG looks like, AFib at least, VFib, you know if there's a block, okay? Then cardiac output. This is this is what we want, right? We want the heart to be able to pump blood, and we assess the health of the heart by checking its cardiac output, which is here.
Stroke volume plus
Stroke
heart
volume
rate.
times the heart rate.
Times the heart rate.
Times the heart rate, okay? So be sure you should be able to compute. And the factors that affect that, you have the preload, afterload, and cardiac contractility. Remember I told you the difference between afterload, and cardiac contractility, and factors that can affect that one. Remember, for preload, maybe increased volume intake. Afterload, there's arterial hypertension, hardening, and then contractility is already the heart itself, MI. If you look at if you study how the pacemaker, so the EKG travels from the atria to the ventricle. You remember the function of the cardiac skeleton? The cardiac skeleton separates, really. Just think of it like an actual separation between the atria and the ventricle, so that the atria is stimulated first, it contracts, then the ventricles next. Remember we talked about that one, okay? Then about when you go to the blood vessels, you should know, of course, the difference between artery, capillary, and vein, the function. And when we talk about blood vessels, their job is to distribute, exchange, and return. So the distribute is the artery, then exchange is the capillary, because that's the only one that has openings, right? And then return, be able to compute for filtration pressure. So what's hydrostatic pressure, what's osmotic pressure, okay? And then regulation of blood flow, what helps in the blood flow in your veins, what helps with the arteries, vasoconstriction, vasodilation. Oh, chronotropic, inotropic, remember? I said I like to ask that. So remember, in the past, what I would do is I would write maybe a few instances that say, tell me, let's say hypokalemia, meaning hypo means low, kalemia means potassium. If you don't know the meaning of the term, just ask me. Let's say hypokalemia or hypocalcemia. What would this be? Would this exert an inotropic or a chronotropic effect? And would it be positive or negative? So how
Negative.
about hypocalcemia?
Hypo, it's low,
Low calcium. So would it
it's
affect
inotropic.
inotropic? Very good. Positive or negative?
Negative.
Yes, very good. So don't forget that part, okay? And I think we should be okay.
Does potassium affect the
Potassium affects-
contracting of the heart or the heart rate itself?
What do you think?
Well, if you're
Potassium
low,
affects-
if your potassium is low,
If the potassium is low, what do you think? Potassium has something to do with
Contraction.
generation of action potential. And we know that the muscles
contraction.
also generate muscle action potential. So, contraction. Lymphatic worksheet, do I have it? I hope you, I hope you, what was I gonna say? Not realize, but what I wanted to say is this one is very practical, the questions here for the lymphatic system. Okay, so today, you're almost, wow.